Hello. So my name is Mughees. I'm a front-end developer, and I work at Ultimate AI. At Ultimate AI, we do automation for the customer support chat. And if you have ever talked to a customer support agent on a website and think that it's very good, very awesome, probably it's a bot. It's our bot. And today we'll be talking about Alias and tuples and how Alias compares to interfaces. Most of the TypeScript community in the initial stages, or like usually when you're building a project, you will see interfaces a lot, and then the type aliases came in, and this is how you define them. There are like small differences between the interfaces and types, and we will go through over them. But let's go through the user journey, how the user comes into these types, and how we separate them. So usually when a user start writing something, it will start writing a function. It will put a parameter in it. As the function will grow bigger and bigger, the parameters will start getting bigger and bigger. And then you will see, okay, we need to take them out. You take them out and you create types. Here I just have an employee which have a type of string or number, ID type. And the employee type can be intern, permanent employee, and probation employee. And then here I just combine all these types into one and make a whole type to pass it to our function. There are twofold benefits for that. If you have your function parameters like these, the problem is that even if you have optional parameters like your probation period is a question mark, there was supposed to be another one, I think here, like share then probation period. But if you have them in line in your function, if you want to pass the last parameter, even though the other two are optional, you will have to pass them anyway, because the functions cannot skip the parameter if you have to pass the last one. By taking it out and making it an object, now you only pass things that you want and then skip the optional ones. You can potentially do the same thing with interfaces. You define an interface ID, an employee type, and then you can define an employee and extend those. But the main thing is that for interfaces, they have to be type named. So you cannot define a primitive type of interface. It always has to be an object with a name in it. And that is where our type alias comes in handy. So just a side-by-side comparison, if we are doing for the types and interfaces. With interfaces, you have animal, you want to extend it to something, you extend it. With types, you have, again, animal. If you want to add, you just use an ampersand sign, and then both of them have same thing in the end. So what you can't do with types and do with the interfaces. So if you have a type name and then you define it again, the TypeScript will start throwing errors that you cannot do that. You can only have one type for one name. If you do the same thing with the interfaces, what TypeScript do is that it just combines both interfaces and make one interface out of it. So if you have interface name and interface name with these three properties, in the end you will get interface which will have name, first name, and last name. Why is it bad or is it good? It depends on what type of project you're doing. But mainly if you have global types or global interfaces, I would prefer types, because then if you try to define something which is already defined by some other user, you can either extend it or look into it that, okay, fine, I need some other type. With interfaces, it's just a mixed box that you define interface globally in one place, same name came in another place, and then you just have a lot of properties that you think where it comes from. This is the same thing that you have two types. You want to combine them. You can combine them as an and sign. You can actually combine two types in an interface as well, but then you cannot pass anything inside it. I mean, if you're just combining them. Same with the interfaces. So if you want to combine two interfaces, you can create a type out of it. So they are more or less interchangeable at this point. Now, we are going to go through things that are that you cannot do with interfaces, but you can do with types. The first thing is the OR operator or the union operator. So if you have two types, you can use this OR operator to tell that, okay, my animal will either be a fish or a bird. And this is the sort of functionality that the interface don't have right now. Also, you can, if you want to do a union type on interfaces, again, you will have to do it using a type, alias type. So in the end, I see more benefit of using type aliases than interfaces. And again, like I was said in the start, that the type aliases have primitive types that you can define in any number of ways. So I can say my name is string and my ID is number, just that. And you probably want to do something like, okay, type info where it can be either a string or an object. And interfaces usually cannot perform these sort of operations. It just really struggles with that. And this is my favorite part of the type alias, the computed properties. So let's take an example that you want to type an object which will have first name, surname, address, maybe age, or like XYZ elements in it. And all of them will be typed as string. So rather than typing them one property at a time, you can use this in property with the key, and it just takes all of the keys and assign a single type to it. How is that useful? Sometimes, I mean, it just gets cumbersome to write big properties when you know that all of them will be of same time. So you just define the keys and then use the computed properties to expand your type fully. Also, not only can it compute the properties from the keys, it can actually take another type and then extend it and create a new type out of it altogether. It can perform some operations like I defined my type as person, and it is name and string. So what I'm doing here right now, I'm saying that all the keys in my T, mark them optional. So because I'm creating a new type out of my old one, I'm marking all of them as optional and then attaching my address string to it. So potentially it becomes what's in the last one. So all of these operations become name, age, question mark, and then address becomes the compulsory one. Why would you want to do that? So for example, you have a type which you use normally, and all of these properties are required. But then came an API which has the similar properties, but most of them are not required. And then you create, rather than creating the new type for all of these properties, you just use these computed property address in your type and just create a new type altogether from it. And it has helped me really in creating these extended types for APIs that I'm using from some XYZ source which I'm not sure of. Okay. This ends the alias versus interfaces. Anyone have any questions so far? Like why we use one or the other? I would say that I am in opinion that we should be using type aliases more in our project. And interfaces should only be used if we are exposing our library to some external source. So we use interface there. Somebody wants to use our library. They have the similar name in their interfaces in their project. It will not complain. It will just merge. It will all go smoothly. Any questions so far?
I think there's only one thing that you can do with aliases. You can't have constructor out of them.
Sorry, what?
So one thing that I think you still can't do with type aliases is when you want to extend or define the signature of a class, you can't have the types constructor done through them. So you need still an interface with the constructor.
Yes.
Hosted inside. So
yes.
This is a big difference.
Yeah, that is one of the big differences if you want to extend your interface. But with types, you can still use the implement functionality and implement the class from it. So you cannot extend it, true, but you can still implement through it. but generally that, okay, this is one of the differences as well, that if it's a static type and you know that you're not going to use classes for it, you're not going to have function in them, or you're not going to have a constructor property in them, then it makes more sense to use type aliases than interfaces. There was another question?
Actually,
Yes.
that was the question.
Okay.
Some things type aliases can't do that interfaces can.
Yes.
Is there anything more though?
Uh,
Something interfaces can do that type aliases cannot.
something that interfaces can do.
But-
No, I think anything that interface can do can be done through type aliases.
I think there's type hosting. So at least it was a feature in the previous version of TypeScript. I don't know if it's still relevant in version 4 plus, but once it was defined that the type, so it is the same difference between var, let, and const, right? So var get hoisted to the top of the file,
Yes.
where let and const, well, change the scope, but also are supposed to be captured at the declaration point and are not going to be hoisted at the top of the file, therefore you could not reference them before them being declared. And the same thing was for the type aliases. So type aliases used to be not hoisted, where interfaces were always.
That I think is not true anymore, because
Even
yeah. Yes.
Can I get the question, please?
I'm very bad at throwing.
Got it.
You. So there is in fact one dimension in which interfaces are better than type aliases, which is editor support. If you hover over a type in VS Code, and that is a type alias, then VS Code will try to show you your documentation. It will try to resolve the type all the way to the bottom, and that will admittedly make some of these types very hard to read, because it will remove any kind of abstraction that you had there or something, and it will make all of your types look way more complex than they are. If you use interfaces for that matter, VS Code will immediately stop at that interface level. It will show you what interface it is, what properties exist, but it won't go deeper and resolve these properties. So if you have types that you expect to be inspecting a lot in your editor, there's this one argument to use interfaces. That's one. And then there's this other very contrived argument, which is if you have, let's say, 1 million interfaces that each extend each other, then through some magic computer sciencey type system thing, types are way less fast to compile than interfaces. But that is if you have like 1 million interfaces, so please don't accept that argument.
Yes. One other thing that interfaces can do is if there is an error, it usually will tell you the exact property in the error that is wrong in the interface, but in types it will tell you the generic types, which is not present. I tend to agree with that point, but overall it's generally my opinion that when we are using internally in our project and we know that we are not going to extend our types or there is no constructor, they are just defining what the object looks like, then the type alias provide more functionality in terms of union and intersection and compute properties. Okay, so then we move on to something which is a little bit controversial because people have asked me like, what's the use case for it? So tuples. What? Yes. that was my answer, but okay. So we want to define an array which is of type string and number, and we are really worried about what is on the 0th index on what is on the first index. In some world where we are worried about that, we cannot define our array using the first method, which is the popular method of defining an array, which is string and number. We use the second method, which ensures that our first element will always be a string and our second element will always be a number. There are a couple of use cases for that. One would be when we are typing our arguments for the function. where we want to make sure that everything comes in order. And second might be that some API needs some special array with different types. It gives a lot of functionality. So if we define, sorry, it's a very big screen. I almost lost the cursor. So if we want to define the string and a number, we can define it like that. If we try to define with the third element, it will give an error on the length. But because it's JavaScript and TypeScript tends to stop you from doing things that should not be done, and JavaScript allows you to do things that are, we can do work anyway. So we can still push the element into the array and it will not complain. But the element we are pushing still has to conform to the types that are of tuple. So if we push 56, it will say it's fine. But if we try to push an element which is a Boolean, it will still complain that the argument type is not compatible with it. And yeah, we cannot change the order. The order has to remain same. And the other thing that when I was saying that it can be used in defining the functional parameters, it is mainly due to the fact that we can name our tuples. And this is the sort of functionality that we don't usually have when we are defining an array through conventional means. So if you know that, okay, you have 4 arguments which are going to in your function, you can define a tuple which will have their named element attached to it. These are just aliases and they don't really matter because you still access the array using the index and you can destruct it as you want. What is the caveat here is that if you're trying or if you're putting the named tuples, each of the element has to be named. You cannot just name one and leave the rest. All the arguments has to be either named or not named. What more it can do is that it can use the spread operator to define some really cool type of things. So if I define something like at least 2 numbers, which has number, and then a spread operator. So what it do is that it will define an array which will have at least 2 elements or X number of numbers. So if I try to pass one element, it will start to throw error. And the other cool thing is that it can have spread operator in the middle of it. So you have your left hand or your right hand which have types, and then in the middle you can have anything. And the spread operator is by default an optional parameter. So if you're defining a spread operator, it becomes optional. Either you pass them or not, it doesn't really make difference. So here when we have a string, a spread operator of number array and Boolean, we can define something like hello 2 3 4 5 true, or we can say hello true. In either case, it works. It will not throw error. The other thing that is with the spread operator is that you cannot have 2 spread operators, because then the TypeScript will get confused, like where the one spread operator ends and the other starts. You can actually do these tuple things in interfaces as well with something like this. So what you do is that you try to extend your array, and then you say that, okay, it will have a number and a Boolean type. And then you define the index in it with a number and Boolean and its length. And then you can use it same as your tuples. But then obviously it's a matter of choice that why do all of this when we can do the simple this. But one thing that is really cool about the interfaces is that you can use some generic types and really get into the basic details of how we are doing the tuples. So here what I'm doing is that my interface will have a generic type of T, U, and L, and which will return an array of type T and U. So I just have to pass what type and what length it has to be, and it will automatically create a type out of it, and then we can use it as a tuple. It is just to show that, okay, we have the tuple types, but when we didn't have it, the similar functionality could have been achieved using interfaces at some level. Questions?
Sorry?
Yeah.
Can you go back to one slide?
Yes.
Wait, do you want to have the cube?
Yeah, one.
All good. I'm good. I wonder how the type. So it looks like only the first two arguments are typed and the rest are not. Is it correct?
Sorry, which
So
one?
like I mean the first two indexes of the array.
Yes.
0 and 1.
So when you're defining your array through an interface like that, it means that your T and U will, the number of indexes that you want to define, and rest of the indexes will have to follow what you have already defined. So
But will be any or will be
No.
the last type then?
So they will be number and Boolean only.
But I mean, okay, but so the second and third will be either
So
T or U. Let's say.
exactly. So that is at the end where I'm saying extend array T and U. That means that it can only return the type T and U.
Yeah.
So and the difference between the first example, I think the slide before.
This is just the normal way of doing doing things, and this is a generic function I've created out of it.
Meaning that I was just I lost the extend array at the beginning. So if you just define an interface with the signature of having like an index number plus a type and a length, then you lose the ability of having all the methods which are attached to the array type, right? Instead here you're extending it, so you're inheriting all of those.
Yes, you always have all the functionality. That is exactly why here, even though I've defined it as a string and a number, I was able to still push it because in the end it's still an array, and you can do all sorts of operation on it. Okay.
So is that also a way how, for example, if you use a library like Axios and you can create basically a function that returns an array where the first value is null and the second is the response, or the first value is the error and the second value is null?
Yes. So that is more or less, you can achieve that functionality using the tuples now. Mostly it has been defined using the interfaces. I have not included a very large example because there was one where there is a function in which tries to combine two arrays, and then the function does not know what type of arrays are, and then you just have to overload like 10 different methods to make it TypeScript compliant. And with something like this, it can be done in 2 lines with tuples.
Nice, thanks.
Thank you. So can you define types with generics?
Yes. So
Because you define this fixed length array as an interface.
yes.
Can you do the same as with type?
So with type, you don't have to because you're already, when you're creating a tuple, it's already length bound. So when you say that
But if you want to reuse this
interface,
this type with different types, so this type should support generics. Can you do this?
with type aliases and tuples, it can. So what you can do is that rather than saying number, you can say TU or TT, whatever you want to define, and then you can pass the types later on. Okay. And it will be length bound. Okay then. Thank you.
Bravo.